In this video, we'll solve basic exponential equations using the one-to-one property of exponential functions. Let's begin by reviewing the formal definition of exponential functions. For positive a not equal to 1, the exponential function with base a is given by f of x equal a to the x. Let's summarize the properties of graphs of exponential functions for review. The points 0, 1, 1, a, and minus 1, 1 over a are on the graph. If a is greater than 1, then the function is increasing, and if a is a fraction between 0 and 1, the function is decreasing. In either case, the exponential function is a one-to-one function. The domain of the exponential function is all real numbers, and the range is all positive real numbers. Finally, the line y equals 0, or the x-axis, is a horizontal asymptote of the graph. We will solve basic exponential equations using the fact that exponential functions are one-to-one. By definition of a one-to-one function, if a to the x equals a to the y, then we know that x equals y. In other words, given equal exponential expressions, if the bases are equal, then the exponents must also be equal. Let's consider some examples using this property. First, let's solve the equation 2 to the x equals 2 to the power of 3x minus 8. We start with the given equation and note that we have equal exponential expressions with equal bases. Therefore, the exponents must also be equal. We can solve this linear equation for x. Subtract 3x from both sides, and then divide by negative 2. We get that x equals 4 is a solution to our equation. Now let's solve the equation 49 to the x equals 1/7. We start with the given exponential equation, but it might not be totally obvious that we have equal bases. So we rewrite 49 as 7 squared and 1/7 as 7 to the minus 1 power. We know that when raising a power to a power, we multiply the exponents, and now we have equal bases. Therefore, the exponents must also be equal. We get that x equals negative 1/2 as the solution to the equation. Let's consider one more example. Solve the equation 27 to the x power equals 3 to the power 2x plus 4. Again, we start with the given exponential equation, and it still might not be totally obvious that we have equal bases. So we rewrite 27 as 3 cubed. When raising a power to a power, we know to multiply the exponents, and now we have equal bases on the exponential expressions. Therefore, the exponents must be equal, and we get that x equals 4 is a solution to the equation. Solving more advanced exponential equations requires more advanced techniques using logarithmic functions, which is to come in a later video.